Hello, everyone. Welcome to this new session from the DSA Summit about new trends and technologies. We are going to have a great discussion hearing from two very recognized regulators from Mexico and Nigeria. And we will also have insights about technologies. And to moderate this panel, we have invited Nwana. For those of you that were not aware, he was the first president of the Dynamic Spectrum Alliance. And at the time that when the DSA was created, some of these technologies were just emerging and first adoptions were starting. And also some of the other technologies we are going to hear from today were not developed yet, were not even in the plans yet. So I'm very glad to welcome Aish. And I invite you to enjoy this session to hear about all this exciting process and news, and also to hear how we are working further to get more people connected and enhance the quality of that connectivity. So, Aish, welcome. The floor is yours.
Thank you so much, Martha. And again, I'm really honored to be back with the DSA. So welcome to this DSA virtual global session on how to connect the unconnected, enabling future-proof technology solutions for everyone and everybody. And I stress the word everyone and everybody, because as Martha has mentioned, I used to lead the DSA, and I know the DSA really believes in affordable connectivity for all. It's part of their DNA. Without any further ado, I would really like to start by introducing our first speaker, who is my friend, the Director of Spectrum Administration for the National Communications Commission of Nigeria. Engineer Dr. Nwaulune, the floor is yours. You've got 7 minutes.
Yeah, thank you very much. Like H said, I am Dr. Nwaulune, the Director of Spectrum Administration of the Nigerian Communications Commission. My responsibility is the management of the radio frequency spectrum, both for terrestrial and for satellite. Please, the next. The outline of my presentation is introduction, available options for the connectivities, then connecting the unconnected, and we'll have a conclusion. Next slide. According to ITU, 56% of the 7.7 billion population of the world are connected, which means 44 are unconnected. United Nations also states that although there is significant rural to urban migration, half of the world's population still reside in the rural areas where there are no infrastructures. A significant effort, I think, and I feel that everyone should agree with me, is needed. Next slide. Next slide. Just a little statistics from Nigeria. We have 149.7 million active internet subscribers as of August this year. Our broadband penetration is 43.3%, still at the same period. The percentage contribution to GDP was 14.3% as at that same time. Therefore, a lot of effort and a lot of things will need to be done to bridge the connectivity gap between the urban, suburban, and the rural areas. And we believe that we require a combination of modes to be able to do this. One technology will not solve it. One mode of connectivity will not solve it. So we need all of them. Next slide. Next slide. Okay. The efforts that we have done to connect the unconnected is that we promoted license exempts in different frequency bands. Recently, we opened the 60 gigahertz for license exempt, which means Wi-Fi can be operated in those bands. We employed light licensing method to the 70, 80 gigahertz millimeter wave band for backhaul. And a lot of things have been done. The DSO is very slow in Nigeria. However, we've been able to get two out of the 3 slots in the 700 megahertz band for 4G and 5G connectivity. We are, as a nation, favorably disposed to using the lower 6 gigahertz as license exempt. You know, there is a lot of debate around the world about what to do with the 6 gigahertz. And with us as a department, we think we give all our support for it to be used in license exempt mode. So we are taking the campaign to every other stakeholders that we need to get on board for it to happen in Nigeria. We have developed guidelines for the use of TV white spaces in Nigeria, and very shortly it will be implementable, to be published for implementation. I think our legal department still want to do just one short public inquiry. And we engage in refarming of frequency bands for more efficient technologies. One of them is the 2.6 that was being used by MMDS operators, which we have repurposed for 4G in Nigeria for broadband connectivity. Next slide. Other efforts, we are developing and deploying spectrum trading guidelines. 5G policy framework is being developed and will be through very soon. We have guidelines on active infrastructure sharing that is still on the way to be completed in a while. We are developing framework for national roaming. Before now, operators are not allowed to roam from network to another, but we are doing a trial on it between 2 operators now, and hope that very soon the guidelines will be completed. Next. There is need for Wi-Fi spectrum very urgently for the consumers. We are at a pivotal moment for the future of Wi-Fi. Wi-Fi has proved to be very great for the connectivity that it provides for operators for offloads on their networks and co, and for it being a shared access technology. So we support the license exempt use of the 6 gigahertz band, the lower, just like I said earlier, and maintaining the regulatory status quo in the upper 6 gigahertz band will allow it to be employed by the most appropriate wireless technologies. So we are saying, yes, the lower part of the 6 gig we are using for license exempt, but the upper band will be left for the most appropriate technologies. Please, next slide. We say there is need to ensure availability of sub 1 gigahertz band for service deployment. There is need for acceleration of digital switchover. We're talking actually for the continent, not for Nigeria, because for Nigeria, we have almost got all, and very soon, without the DSO, we will be able to get a 3 spectrum band. And we think that there is need to expedite releasing of critical spectrum for shared use. Nigeria strongly support shared use of spectrum. And I'll just conclude with the fact that Nigeria also puts its weight and support behind TV white space because of its shared use. Thank you very much. I think my time is gone. Thank you.
Engineer Dr. Nwaulune, that's really been a good rundown of what's happening in Nigeria. I'm really, really pleased to see the amount of different and disparate efforts that you're doing currently in Nigeria. Let me just ask you a few questions. The first one really is about this satellite. You mentioned satellite very briefly, and that you're looking to work with some operators to try and get them to get satellite connectivity pricing down to that of terrestrial services. I know you say it's still work in progress, but can you say a few words about that, engineer?
Yes, over the years, I have been engaging satellite operators because I didn't know why they will always only play complementary roles. And they tell me that the reason is pricing. So I was glad very recently when I discussed with a couple of satellite operators, and they said they are coming to Nigeria and they are going to deliver service at the same price that the terrestrial operators, or even lower. So that was why I called it promissory notes, because it's not done yet. But they made us to believe that the cost of launching satellites, which is the major cost element in satellite technology, has come down significantly because the launching vehicles are now being reused, unlike before, that once they are produced and they go into space, they don't come back. But now they go and come back and launch again. And we have a lot, like we have 172 GSO spacecraft that we have granted license landing rights in Nigeria, and 119 non-GSO spacecraft that we have also granted landing rights. They are from 68 satellite space segment providers. So from the 68, we have 172 plus 119. And it's very promising. Some want to come and do trial, family and friends, and by 2021, we are going to have that being rolled out in Nigeria. And also the Loon idea, the HAPS idea. So I think that even the broadband target that we put in our program plan of 70% by 2025 might be achieved in 2021 if what the satellite operators are telling us come to pass.
That is fantastic, engineer. I think we'll try and create some space to ask you some more questions at the roundtable session of this call. So let's move to our second speaker of the day. It's really my honor to introduce Commissioner Arturo Robles Rovalo of IFT in Mexico, a regulator who I really, really admire all the time, and I'm always looking out for what IFT is doing, not least some of the fantastic work that you guys are doing on the wholesale access network in Mexico. Commissioner, you've got 10 minutes, sir. Thank you.
Thank you, Mr. Nwana. It's a pleasure to be here, also sharing the table with you. First of all, let me say good night to the people in Europe, Middle East, and Africa. Good morning to the people in Asia, and of course, good afternoon to the Americas. I really appreciate this invitation from DSA and the opportunity to share the point of view and the experience of the Instituto de Telecomunicaciones from Mexico on this very relevant topic. Next one, please. During these critical times, internet connectivity has become a central element for many of us. However, the remaining lack of connectivity in some regions also highlight the great difference that still exists between connected and not connected population. In Mexico, the orography represents a major challenge in bringing telecommunication services, including broadband and internet, to the entire population. Mexico has almost 80 million internet users, the 70% of the population, and most of these people are connected through their smartphones. The access gap between the urban and rural population is 70% versus 48%, which clearly increases the inequalities and the lack of opportunities. Not everyone has the same digital opportunities, which generates a new source of discrimination known as digital divide. Even more, in this world crisis that we are living through the COVID-19, today is more evidence that the internet access is crucial to grant access to health, education, work, and other human rights. Next one, please. So what is Mexico doing to connect the unconnected? Well, the IFT granted a license for the deployment of a wireless nationwide network using the 700 megahertz band under a public-private partnership model. It is expected that this network will cover at least 22% of the national population by January 2024. Also, in the auction of 2.5 gigahertz bands, IFT included some coverage obligations that includes to cover towns that do not have a mobile service, the highway sections of the former special economic zones that are zones with low-income population, and metropolitan areas with a population of over 1 million people. Next. Mexico is also supporting universal service with programs and projects based on licensed spectrum. There's a project that is a leader by the former energy company known as CFE Telecomunications, and it will be able to provide the services nationwide, except in locations with connectivity, as well as free internet access service in public sites. This is a public and a governmental network, and they could use unlicensed spectrum frequency bands. Also, right now, the IFT is working to submit a new technical operating conditions for the band of 74 to 21 gigahertz for public consultation. And in addition, regarding this important band of the 6 gigahertz, the Institute is working on a document that will be soon be submitted for public consultations, so that everyone interested to participate can provide their comments on the most appropriate use in Mexico. As some of my colleagues just talk about, there are the next one, please. There are also a very important element for Mexico that there are the satellite networks. They are the third component to connect the unconnected. In this regard, the IFT recently awarded 40 megahertz in the frequency band of the 2000 megahertz for ancillary terrestrial services, also known as complementary ground services. And additionally, the IFT plans to auction the upper part of the 2.4 gigahertz band for the next ground complementary service of the mobile satellite service for the next year. Additional, the IFT is also preparing a new set of rules for satellite communications that will consider the technological evolution and the new satellite solutions as the complementary ground components, the short-term mission satellite services, the VSATs, the M2M satellite communication devices, and these new suborbital vehicles. But also, please, the next one. But also, we are looking for more alternatives and more innovative technologies. We are also studying new and technologies as HAPS and HIPS. These technologies could be a feasible solution to provide national-wide broadband coverage with reliable, fast, and affordable connectivity. Using these HIPS, in addition to ground-based IMT base stations, mobile networks operators can cover these areas in economically and efficiently way and contribute to the country's economic growth. These innovations are adding a new layer to the global connectivity ecosystem, making it possible to connect billions of people and things in isolated places. So almost all of you, the next one, please. This is very familiar for you. These are the techniques and the methods that we are considered for these new rules and for these spectrum access sharing conditions that consider frequency separation, spatial separation, time separation, signal separation, and also the TV white spaces to connect the unconnected using spectrum sharing techniques, as could be the cognitive radio technology. Next one, please. Finally, I would like to highlight the role of the community networks. These community networks is a regulatory tool that is working very fine in Mexico to connect the unconnected. These kind of licenses are an important solution to bridge this digital divide. This connectivity is bringing economic and social benefits to rural locations, including access to e-commerce, to telehealth services, to distant education, social and political engagement, and government service and public safety information for everyone. With this license, some communities and some rural people could access to a spectrum and provide in a communitary and public basis the mobile and the cellular service in these rural areas. They also could use the secondary markets and the secondary use of a spectrum, and EFT just make available the specific bands around 850 megahertz for this kind of community licenses. Next one, please. And to conclude, I would like to share with you which are the main regulatory challenges for Mexico that we identify at IFT. Well, there are the TV white spaces that we need to explore a more flexible regulatory framework. We need to promote an efficient use of the spectrum under licensed and non-licensed models based on dynamic access and spectrum sharing technologies. We need to improve the regulation that foster connectivity in unpopulated areas, and to allocate the spectrum identified for hubs and HIPs to promote their development. Finally, to establish new operating parameters that guarantee non-interference between satellites, hubs and HIPs, and the current mobile and fixed services. Thank you for your attention.
Previous speaker, Director Nwaulune of Nigeria, you covered quite a lot of ground there. Quick one, Commissioner, is Red Compartida now called Enero?
Sorry?
Is Red Compartida now called Enero?
No.
Because we saw on your slide Enero rather than, I used to
January.
think that,
January?
No, for the wholesale access network.
Yeah, the wholesale access network in Spanish is Red Compartida, and Red Compartida, that means wholesale network. And as you know, there is a national-wide project that we granted the 700 megahertz with a special low price for the spectrum. And the winner is not the one that offer more money for this spectrum, but it's the one that offer more coverage. And they offer 22% of the population covered by 2024, I think.
Okay, no, that's fantastic. So thank you so much for that clarification. But I also noticed that you had a new entrant into the marketplace in AT&T, and I think it made quite a big difference in Mexico compared to maybe the wholesale access network. Can you comment on the entry of AT&T into Mexico landscape? Thank
you. As you may know, there was a telecommunication reform in 2014, and this allowed the entrance of new competitors. And we previous of that reform, we have two mobile networks that are Telefonica and America Mobile or Telcel, and then entered AT&T, but they have their own network. There are also these new wholesale network that they provide access not only for the former operators, but also for MVNOs. Actually, there are a lot of MVNOs right now that they are using this wholesale network. So there are two kinds of markets, two kinds of competition. And this other project that I just talked about, these telecommunications, Internet para todos, that means internet for everyone. They are a governmental network, but they are not competing with this network because they are only allowed to provide services in public sites and in small towns that do not have this connectivity. This is the other 8% of the population that will be not covered with this wholesale network.
Thank you so much, Commissioner, for that. And you also mentioned social use, which I really, really enjoy and I really liked. Companies like Rhizomatica. Do you have a number of what sort of numbers of Mexicans are now covered by social networks, by social community networks like that, sir?
Right now, we have granted two licenses for two licenses, but they can use this in different towns. So these two licenses, they could cover cover not only one town, but they can use it nationwide in a nationwide basis. They can go and they could make some agreement with this community. This community make the commitment of operate the network, and they receive technical support in order to manage the network. So there is a very low price and an affordable and a long-term solution. And in return, we granted this spectrum with very, very, very low prices, and they do not have to pay the rights for using it yearly.
No, thank you, Commissioner. I really hope other countries would look at what Mexico is doing with things like community networks as well. And last but by no means least, for now, Commissioner, what are some of the main challenges in developing rules for satellite communications in Mexico?
Well, right now we are working as I just mentioned. We are working in this. We are working in these new rules that they cover new systems and new. Just give me a moment and new. And new solutions. They are covering right now these low orbit satellites. They are covering also these the ground component systems, and they are also offering. We are also considering these high satellite capacity networks. We are also making the management of the grandfathering rights for the coexistence between satellite and new e-commerce, the other services that they are incumbent on, that they are right now providing some services. And this ensures that the satellite investment already done in Mexico, and that new solutions at these hubs and hips could enter to Mexico. We also are proposing a blanket license for Earth stations. This means that with just one license, you can deploy a lot of Earth stations, and you just have to make the registry later in order that we have an updating registry. But you can deploy a lot of Earth stations with just one license.
One license. So well done to you, and continue to do the good work you've always been doing at IFT, Commissioner. Thank you so much for now.
Thank you. It's always a pleasure to be here.
Now, without any further ado, let's move on to Julie Zoller of Amazon. She's going to introduce us to a fantastic new project called Project Kuiper. Julie, you must have already heard Austin from Nigeria, Director Austin from Nigeria mention NGSO. So I hope that gave you some joy. So over to you, Julie Zoller of Amazon. Thank you so much. You've got the floor for 7 minutes.
Thank you so much, H. And you couldn't see me, but every time the word NGSO, satellite, or LEO was mentioned, I was definitely smiling. I really appreciate the opportunity to participate in this summit and to share some information about our exciting satellite project. Project Kuiper is an Amazon initiative to deliver high-speed, low-latency broadband connectivity to unserved and underserved consumers and businesses without reliable broadband through a constellation of 3,236 satellites in low Earth orbit. Kuiper is a long-term project, and the team is making incredible progress. We've already marked a few important milestones this year. In July, the U.S. Federal Communications Commission granted our license with a unanimous vote, authorizing Amazon to deploy and operate our LEO system. We're hiring and growing quickly, assembling a team of world-class scientists and engineers to deliver on this vision. While my team is in the Washington, D.C. area, most of the Kuiper team is in Redmond, Washington, where we have an over 20,000 square meters state-of-the-art facility that serves as the primary headquarters for research and development and early manufacturing. Amazon plans to invest more than $10 billion to build and scale our ground network, accelerate satellite testing and manufacturing, and deliver an affordable customer terminal that will make fast, reliable broadband accessible. Could I have the next slide, please? I'm often asked why Amazon has committed to Project Kuiper. At Amazon, our energy comes from innovating on behalf of customers. As was previously noted, there are billions of people around the world who lack access to broadband internet, and that's not acceptable. As the ITU reported in August 2020, nearly half of the people aged 10 years and older, or nearly 3 billion people, have never used the internet. Without broadband connectivity, these rural and remote citizens miss out on educational and employment opportunities that many of us take for granted. Amazon has the people, infrastructures, and resources required to deploy and operate satellite broadband services to underserved and unserved communities, and to expand opportunities for citizens around the world. Next slide, please. This shows the Kuiper system architecture. I'll start with the left side of the slide where you see our customers, the unconnected or unconnected consumers in the home, commercial broadband users such as schools, hospitals, and businesses, and finally the telecom mobile backhaul market, where we can enable 4G and 5G expansion into areas without fiber. Our satellites are state-of-the-art, and the complexity of our system is in space. We'll have 3,236 satellites at 3 altitudes and inclinations: 630 kilometers, 610 kilometers, and 590 kilometers. We chose these low orbits for customer experience and space safety. On the customer experience side, our customers expect a fast network, and that means low latency. Because our LEO satellites will be so close to the Earth, about 1/20th of the distance of a geostationary satellite, the round-trip time to the internet will be about the same as fiber. On the safety side, gravitational force alone would deorbit a satellite at 600 kilometers in less than 10 years, but we'll actively deorbit our satellites at the end of mission life in less than a year. Space safety is an important Kuiper tenet, and leaving space clean is a responsibility we take seriously. Our satellites will have phased array antennas that produce small steerable spot beams. We'll have the ability to choose which satellite to use for which service area and adjust power and the part of the spectrum we're using real time. Being able to dynamically shape beams and reassign spectrum to different channels allows us to optimize our service to customers as well as to share spectrum efficiently with other services. We're going to build the constellation in 5 phases, starting with the highest altitude, highest inclination shell. In phase 1, we plan to launch 578 satellites. This is half the satellites in the 630-kilometer shell and enough to start service. In phase 2, we'll begin to populate the shell at 610 kilometers, and we'll continue building out the orbital shells through the 5 phases when all 3,236 satellites will be operational. We're an all-Ka-band system with downlinks in the 17.7 to 18.6 and 18.8 to 20.2 gigahertz bands, and uplinks in the 27.5 to 30 gigahertz bands. Our gateway terminals are parabolic reflectors, or the typical satellite dish we're used to seeing. The satellites and earth stations, though, are only part of what it takes to build a global satellite network. Much of the effort happens on the ground, moving and storing data securely, delivering terminals to customers' homes and businesses, customer service and billing, all important aspects of the satellite broadband business and customer experience, and areas where Amazon has extensive knowledge. Next slide, please. We know from experience, and the recent ITU report confirms, that bringing unconnected citizens online requires an enabling regulatory framework without burdensome administrative and regulatory processes. For Project Kuiper, there are 3 essential ingredients: spectrum, a licensing regime for NGSOs, and fair sharing rules. We need Ka-band allocations for non-GSO fixed satellite service systems in the 17.7 to 18.6, 18.8 to 20.2, and 27.5 to 30 gigahertz bands. We need a licensing regime that enables timely grant of the necessary licenses in each country, whether they be landing rights or gateway terminals, blanket licensed customer terminals, spectrum use, equipment certification, or telecommunication services. And we need fair sharing rules. We've designed our system to share with co-frequency systems, both terrestrial and satellite. Sharing rules that enable new entrants like Kuiper are the essential 3rd ingredient. It will take all of us working together, industry, regulators, policymakers, and citizens, to bring broadband to the unconnected. Amazon is committed to Project Kuiper, and we look forward to working with all of you to help solve the digital divide. Thank you.
Thank you so much. I can't tell you how happy I am as an African to which houses many, literally hundreds of millions of unconnected, to see Amazon get into this space. You started with a slide on you guys doing this. Can you just say a few words as to, is this really an Amazon initiative or is this a Jeff Bezos initiative? Can you just tell us a bit about it? Because it's not obvious to many people why Amazon really is doing this.
This is an Amazon initiative, most definitely. It's not a separate initiative on the part of Mr. Bezos, who is, of course, the head of our company. But yes, it is a full Amazon initiative.
Fantastic. And how can the ITU support with an enabling framework so that you can really try and maximize covering this 3 billion market, addressable market out there?
The work of the ITU is super important for satellite systems, and for a system like Kuiper, which is global. I can't overstate how important the work of the ITU is. We submitted our ITU filings back in March 2019. We've already received favorable findings from the Radio Communication Bureau. We know our coordination requirements, and that gives us a solid regulatory foundation internationally. As you know, the work of the ITU in improving the radio regulations is never done, and we're very active in the WARC 23 preparatory process. For example, WRC 23 is going to provide more clarity on bringing into use and deployment milestones for non-GSO systems.
Completely aware of that, and good luck with that piece of work there as well. What's the typical service reach of Project Kuiper, Julie?
We'll be able to serve continuously from 56 north latitude to 56 south latitude. As I mentioned earlier, we're building our constellation in phases from the outside in, so we'll start at the most southern and northern latitudes and build our way towards the equator.
Thank you so much. I'll ask questions later again to you, Julie, but I'm really excited by Amazon doing this work.
Me too. Thank you.
My friend, good old friend, Mr. Sidney Roberts, director at Airband at Microsoft. Sid and I have been trying to connect the Unconnected for many, many years. Sid, over to you to tell us what Airband is doing these days.
Thanks very much, H, and I'm sorry that we could not rendezvous in Paris this year. So again, my name is Sid Roberts. I'm the Director of Engineering on Microsoft's Airband initiative team, and I'm very happy to be back here at the DSA. Let's go to the next slide, please. I always like to start with a rudimentary fixed wireless network design, which I call the hybrid network topology. I'm simply showing a high capacity fiber coming into a distribution tower, and then I'm showing 3 different geographical areas. The points that I like to raise on this kind of a diagram is that, number one, it's not compulsory that the distribution radio networks in each of the green areas be the same. Now, there may be an argument for operational and maintenance purposes, but when you think about it, when you think about that you have consumers, you have SMBs, and you have enterprises, you have a multitude of use cases. So one of the first things that we need to make sure that we do for comprehensiveness is to understand the use cases, the coverage, and the capacity requirements. And as everyone knows, not one radio in general can meet all of the requirements. So that's something that I spend a lot of time emphasizing. The second point of this topology slide is that with proper planning, there can be outstanding improvements on total cost of ownership optimization. When you think about building a fixed wireless network, it behooves you to do the design properly once, and then to do the deployment of the multiple technologies simultaneously. So if you take, for example, a mast that has both near-in use points as well as far away connectivity points, it may well be that you can utilize 2 different frequencies and 2 different technologies on the same mast. And with the proper design and planning, if you arrive at that site and deploy both technologies simultaneously, that brings excellent total cost of ownership improvement. I'd like to go to the next slide, please. And this is a quick review of the radio toolkit plus some extra pieces, which I'll mention briefly, for all the regulators that are looking at how to get started with these kinds of networks. I have arranged the technologies from the top of the page to the bottom of the page, and they are in frequency order. In other words, the low frequency to higher frequency, which also indicates a corresponding low throughput to maximum throughput in the same order. But if we start at the top of the heap there, we can see television white spaces. This is a tool in the toolkit that has excellent utility, especially in sparsely populated areas. And by the analysis that we've done, when you're looking at household densities of less than 15 to 20 households per square mile with rolling terrain, and with the characteristic that you cannot hit those endpoints with a line of sight technology, then that is the sweet spot for television white space, and it's a powerful tool. If we keep heading down the stack, there's still, depending on the region you're in around the world, lots of 900 megahertz, and there's a rich portfolio of radios with a variety of price points in the 900 megahertz. If we move on down to the traditional mid-band radios, which we're all familiar with, again, there's a lot of different trade-offs from TCO as well as operational concerns, but the good news is that it's there and there's a lot of capability. In the United States, we're seeing a lot of uptick in the 365 gigahertz arena. This is designated as CBRS. This is very interesting because it relies on standardized protocol in general, the LTE and 3GPP protocol, which leverages mass production and very attractive pricing on client devices is something that you see here. I also highlight on this line that we're heading into the Wi-Fi 6 area, so these mid-band radios, not only will their frequency range be opened up to allocate the additional spectrum that is coming, but there will be also higher and improved protocols with the Wi-Fi 6 that are going to be very attractive. If you keep going up in frequency towards the millimeter range, there is a rich portfolio of products that, in fact, multi-mode products that can leverage the millimeter wave bands. These are sometimes unlicensed, sometimes lightly licensed, but the point is that you can get super high capacity at very low price point when you need to span short ranges, and this can be a very powerful use case. I just summarize on the right-hand side, just for completeness, that there's a lot going on in the 5G space, and I'm not going to emphasize it here. Similarly, my colleagues on the panel have spoken about the non-geostationary satellites and the LEOs. That's an exciting arena, as well as tethered balloons and HAPS. So there's lots of tools in the connectivity toolkit, and my best advice is to spend the time planning at the beginning to design these networks. If I could go to the next slide, please. I just want to say a few more words about television white space because our focus is in the rural unconnected region. Again, this is just making use of the unoccupied broadcast channels where they exist. In the United States, those channels are 6 megahertz wide. In lots of other places around the globe, those channels are 8 megahertz wide. And to the extent that those channels are not allocated to a broadcaster, and to the extent that we are far enough away from the broadcast locations, then under the control of the white spaces database, we can receive the list of available channels to make use of and to generate traditional point-to-multipoint fixed wireless systems. The first test is always with the database. That is a necessary condition, but then I encourage my partners to get out there with a spectrum analyzer to make sure that the purity of the channels is consistent so that you can reach the service level agreements that you design into the network. Next slide, please. The great news about TV white space, and I've been working in this arena for about 8 years now, is that the evolution of the equipment has been outstanding. In the early days, we had some troubles with having what I talk about features on the left-hand side of the radio, which to me means the networking interface. We're trying to strive for, we'll never get zero touch, but we want as low touch installation and maintenance and management as possible. And the radios have come a very long way. And then on the right-hand side of the radios is where I refer to the RF features or the radio features. And we now have radios that can not only bond contiguous channels, but can also aggregate groups of contiguous channels, as well as MIMO and a host of other features, including world-class schedulers that help to mitigate interference. On the graph at the right, the new radios can produce in the pristine environment that we all know we usually do not see in the radio world, but the radios do have the capability to produce hundreds and hundreds of megabits per second from the base down towards the clients, and then the client can speak back on the uplink, and we have just amazing performance that's available now. That's really what I wanted to say, H, so I'm going to turn it back over to you today. Thank you.
Thank you so much, Sidney. Really important area of updates you've just given us there. Can you just say a few words about the updates on TV white space equipment pricing and all that stuff?
Yeah, I can give you a little bit more, and thank you for the question, H. I mean, it has been a long road to the extent that we've stumped our toes a little bit, but now that we have much more feature-rich left-hand or networking and management features, and then the radio side has followed. The radios that we'll see next month from multiple vendors have this much richer feature set. And what I think we're going to see, and especially in the areas where this spectrum is pristine, and I've outlined the methodology for making sure that that takes place, is we're going to have a lot more happier regulators. We're going to have happier subscribers making use of this technology for the right kind of use case.
That's fantastic. So thank you so much, Sidney. And last but by no means least for this session, let's move on to Wesley Eddy from Loon, an alphabet company. Wesley, you've got the floor for 7 minutes.
All right, thank you very much. So I work for Loon, and we are very happy today to participate in this panel on connecting the unconnected in technology solutions. The topic is very closely aligned with our company's mission. Loon's primary corporate mission is to develop and operate new technologies for providing connectivity in places where it's lacking. And so this panel is actually what we do. I will quickly share some of our accomplishments. You can go to the next slide. So Loon is addressing the connectivity problem first through our network of HAPs flying in the stratosphere. These form a mesh network and relay communications between users and the LTE core network. The relaying spans multiple hops through both balloon-to-balloon and balloon-to-ground links. We've been providing LTE services already in Kenya, Peru, and Puerto Rico, supporting operators in mobile network expansion and disaster relief. The access is provided with our balloons that act to the user like they were traditional cellular towers. They provide a compatible eNode B interface to the user equipment. And we're also using HAPs to support worldwide disaster preparedness services. In order to make this all work, we have developed new technology across the board, from the flight systems that operate in the HAPs for hundreds of days in the stratosphere, the software and other systems on the ground that support operations, and of course, actually in the communications and networking hardware and software that we use. Some of our innovation is in the E-band millimeter wave radio links that we use to connect both balloon to balloon and the balloon to ground links in our network. These are highly directional steered beams, and they make use of our sophisticated radio network planning, control, and management software in order for them to operate effectively and for the network to work end-to-end to provide the necessary ensemble of user services. So go to the next chart, please. So the network brain of our system is a software-defined networking, or SDN, controller that plans the traffic flow routing across the network, and it instructs all of the antenna and radio systems in the network on where to point and how to operate, what radio channels to use, power levels. All aspects of the network are controlled by this system. And then relevant to this panel, a key facet of the future proofing that we've done is that this SDN controller is actually not specific to HAPs that you would normally associate with Loon, but it's actually designed from day one to support other types of challenging access networks that are also dynamic in time and space. That includes other types of airborne platforms. It includes the LEO or NGSO satellite constellations, and also terrestrial microwave and other types of networks that other companies are working on, and some we've just heard of. In addition to using it for ourselves, so we offer the SDN controller as a service to other providers. Our SDN controller can actually stitch together different types of networks in order to provide hybrid coverage. It does this by selecting and orchestrating the access technologies to support users in regions with different coverage density needs. So this could actually create seamless coverage when traveling between a city with terrestrial infrastructure, then moving out to more and more remote areas and handing off between, say, LEO satellites, HAPS, and GEO satellites as needed. So go to the next slide, please. So the SDN control, it includes setting up all the radio frequencies, bandwidth for channels, and power levels, and other aspects of how links are configured. In doing this, we have to comply with all the relevant spectrum regulations, and particularly in E-band, we need to respect other point-to-point users and radio astronomy users. So to make this all work, we need good automation interfaces between the SDN controller and different spectrum usage databases. These databases are really essential to future-proofing, given that the spectrum is limited and desirable bands are becoming more and more congested. Dynamic access methods can actually help to boost the efficiency for using these bands a great deal. In bands where there is active operator coordination, spectrum access systems or other types of dynamic access will be enabled. This involves keeping the relevant spectrum usage information in each region in some type of database. And to help spectrum-dependent users, the data should be accessible electronically and kept accurate and up to date. For more highly dynamic spectrum access, there needs to be a means for network computer systems like our Loon SDN controller to query, synchronize, and operationally use data between different countries or regions. We have worldwide networks and not yet worldwide standards established for this. So it's a productive direction for technology to be created and deployed in. At Loon, we are supporting emerging industry standards for spectrum consumption messages and spectrum policy descriptions that are machine readable. These can be very helpful to enable efficient and flawless exchange of the data in the future, machine to machine. So we're encouraging other people to consider these as well. And I want to give time for the actual full panel questions. So just say thank you for the opportunity to share on this panel. And back to you, H.
Thank you so much, Wesley. A lot of people are really fascinated by HAPS, including me, not least people like you who are dealing with lighter than air HAPS balloons. So can you just tell us, how does it navigate, given that it's lighter than air, subject to wind? Tell us how it navigates in the stratosphere, and where does it start, where does it go?
Yeah, it's a really interesting engineering problem. So we have a few different launch sites in the world, and can actually launch balloons every 20 or 30 minutes with an auto launcher system. There's multiple wind currents in the stratosphere and at different altitudes. And so our HAPS fleet is actually taking wind data measurements and sampling the winds all over the world. It's feeding the data into machine learning models. And so we actually use an artificial intelligence in the cloud to figure out for a given balloon's destination, how to get it where it needs to be by picking the right altitudes and finding a path across whatever part of the globe it needs to traverse. It's all fully automated and allows us to operate a whole fleet of HAPS navigating in the stratosphere autonomously.
How many hubs do you have typically covering an area? So like the Kenya project, how many buckets do you have?
It depends, and it's highly variable. I actually always encourage people to check on Flight Radar 24 website, because then you can see live how many are in a given area. But it can be in the dozens for a given service region at the moment. And of course, we hope to serve more and more regions, so there will be more and more of them in the future.
Thank you, Wesley. Can you bring up everybody right now, if you don't mind, Megan? I just want to thank all of you, Commissioner Engineer Austin, Nwaulune, Commissioner Rovalo, Julie, Zoller, Sidney Roberts, and Wesley. I think it's been an absolute excellent panel, really providing quite a panoply of different solutions out there. But if you don't mind, I'll go back to the Commissioner just to throw you a question as a regulator. Which of these solutions do you think is going to probably move the needle the most in Mexico? And I'm going to ask the same question of Director Nwaulune afterwards.
Well,
Commissioner.
Thank you, H. I think that, as I mentioned, we are analyzing and using different technologies. We start with this red compartida wholesale network that is LTE in 700 for the 92% of the population. We already have all the other bands and cellular bands for these three big operators: AT&T, Telefonica, and American Mobile. And then right now it is working very fine, the KA band for these rural areas where they are making something called Wi-Fi, community Wi-Fi. They make like in a small store, in the village store, they establish an antenna and they establish a link, and they offer Wi-Fi on demand, and they sell codes in order to use this internet. Also, we right now with the pandemic, we are established some zero rating agreements with the operators in order to access to health and education sites, public sites, because there are people that even they are covered by television, they are not covered by any other network besides the cellular. So right now, this combination of cellular, of satellite, and in some cases with wireless fixed access, they are complementing, and we are improving the coverage with these three technologies.
Thank you, Commissioner. And the same question to Engineer Dr. Austin, please. You and I come from Africa, lots of unconnected Africans. How are we going to move the needle with lots of these options you told us this afternoon?
Yeah, thank you very much, H. I am so excited at the promise that satellite seems to bring on the table. So if that promise is fulfilled, I will give it to satellite and Wi-Fi. Satellite will take it to the community, Wi-Fi will spread it in the community. So with those two, in the rural areas and the suburban areas and even the urban areas, if they are able to deliver the capacity that they are promising and at the price they are promising, our rural communities will be heaven here on earth as per communication infrastructure.
Julie, what do you need from Austin, from Nigeria? Nigeria is the biggest country in Africa, Julie, so hopefully you should be targeting Nigeria at some stage. What do you need from Austin, Julie?
Absolutely. I would say it's the three ingredients that I talked about earlier. It's spectrum, it's licensing rules for non-GSO systems like ours to apply for licenses, and it's fair sharing rules so that we can enter the market and share with other services.
And same question to you, Wesley. What do you need from somebody like Austin?
Yeah, so Loon, as a HAPS provider, we're a little bit different than satellites. So we have to work with like air traffic control authorities and get overflight permissions. So it's a little more than just spectrum. But we actually work with cellular operators on those aspects as well. So we use the spectrum that the operators already have in an area. And since we use it a little bit different way, sometimes we have to do some work with regulators. But I think that's basically the difference between us and the SATCOM solutions.
Sid, you've been doing a lot of work, not only in TV white space, but all of these different fixed wireless access sort of models that you showed on your chart. Where are you now? Just give us an update of where you are now with a lot of the TV white space trials that Microsoft executed in the past. What is Airband now trying to achieve? Because I don't think many people outside the States now know what Airband is trying to achieve.
Yeah, thanks very much, H. Well, the idea, and as you recall, in the years gone by, we planted a lot of pilots on many continents, but that's not really what Airband is about. Airband is about trying to help to close the digital divide and to bring digital transformation and affordable connectivity. The key is making use of all of those tools in the radio toolkit. So if you say, Sid, what is Airband about? And share that message is about, we want scalable networks with partners that want to transform their communities, and Microsoft can help with our cloud services and all of our products and all of our digital content to the maximum extent possible. So that's the broader goal. So it's not just about any one technology. The key is to get the connectivity that's affordable and to meet the partners where they are and to transform those communities for the betterment of all.
Thank you. Julie, I know it's still early days of Project Kuiper, but when am I going to start using services of Project Kuiper? Can you give me an estimate?
This is a long-term project, H. We're not ready to announce a time frame for launch of service, but certainly we are meeting our milestones as required by our license.
That's pretty good. Can I just move back to Commissioner for a second, Commissioner from IFT? I've always admired what you guys at IFT are doing, all of these different approaches that you're doing to connect the unconnected in Mexico. Which would you say has been the most, apart from Red Compartida, which was a massive intervention in Mexico, which would you say is the next most successful of all of the regulatory and policy positions that you guys have taken, which other countries could learn from, Commissioner?
Well, besides this regulatory tool that is the communitarian license, that they foster the coverage because it is easy to access to the spectrum. We are right now fostering and pushing the use of new technologies in satellites. We are looking for LEOs, we are looking for HAPs, we are looking for HIPs. This new set of rules that we are preparing right now and will be released in a few months, they are covering these kind of solutions because we are sure that we need this kind of new solutions for Mexico. Also, we are working in shared spectrum at 6 gigahertz for Wi-Fi, and also for the upper part we are analyzing if we will use for 5G, and we are studying the new bands. We right now use 28 megahertz, the Ka band. We are keeping it for satellite because right now they are very good results with this Ka band solution to make the backhaul and then spread it with Wi-Fi in small towns.
Thank you so much for that.
Community networks are the key.
Sure. Back to you, Engineer Austin. I was very happy to see you mentioned unlicensed spectrum, because many times across the world, particularly in Africa, regulators do not really see the importance of unlicensed spectrum. So congratulations to you for prioritizing that. Can you just say a few words about using unlicensed and TV white spaces in Nigeria? When do you think that will start happening? And what do we need to do to start getting such services in northern Nigeria, in Yola, in different parts of the country, which are not connected today?
Yeah, if I understand the question, you're asking
so my question is when is TV white space going to be? When is TV white space going to happen in Nigeria? And I really like to know a bit more about how you're really promoting the use of unlicensed technology in Nigeria as well, please.
Yeah, I'll start from the second question. How are we promoting it? What we do is to develop clear guidelines and framework that operators abide by. We don't give them license, but we regulate them. So we give them conditions under which they play, and we leave them to play. Then for the TV white space, I think we are very close. I thought by now we should have actually published, but there was a legal requirement by the legal department. We thought we had crossed that because we have done consultation twice on TV white space, but they said we did not do it according to the law. According to the law, there are timelines that you have to give for different publications. So once that is done, we get it. I'm sure by the first quarter of next year, if not before then, it should be published for use, yes.
Thank you, Director. 45 seconds for concluding remarks from all of you. 45 seconds only, starting with Wesley.
I just like to say not just for HAPS, but for other types of access systems that people have been talking about. Our software-defined networking controller, we think it's very, very important to promote the use of databases and spectrum sharing information systems.
Thank you, Wesley. Julie?
It's been very gratifying to participate in this summit and to see the technological innovations that are coming down the pike. I'm really proud to be part of the solution for bridging the digital divide, and I look forward to working with everyone.
Commissioner.
Thank you. Well, the big conclusion is that there is no one fit for all solution, that we have to try a lot of technologies and a lot of regulatory tools. And with one of the biggest keys here will be the spectrum sharing.
Director Austin?
Yeah, just to say thank you to everybody who's been on this platform tonight. And to thank you, H, for moderating the session. And I want you to pass the message to the satellite operators that the heavens is open for them to come and deliver to us on their promise. We are waiting for them. We are eager to have them. Our rural communities need development, and that infrastructure is part of what they need for development, just like they need the roads. Thank you very much.
Julie, you heard him, right?
I heard him loud and clear.
And last but by no means least, Mr. Roberts, Director Roberts.
Yeah, well, again, it's been a pleasure to be on this panel, and we all share a common theme and a common goal, and that is to be partners in rural connectivity. So Microsoft is there, and we look forward to the future ahead, working in digital connectivity and closing the digital divide.
For me, as somebody who is both a techie and an ex-regulator, and really, really keen to see a solution to the digital divide, I'm getting more and more excited and more optimistic. Because when I see some of the technologies emerging, not only NGSOs or Loons or HAPs or HIBs or all of these different technologies, I'm now beginning to believe that the digital connectivity gap over the next 10 years is almost certainly likely to be bridged. And I would like to pass the floor back to Director Suarez. Thank you so much for giving me the opportunity to moderate. Thank you.
Thank you very much, Aish, for this session. And thank you, a big thanks to all the speakers. I think it was very interesting. We had like interesting questions and answers. And what I like, it's like we are recognizing the efforts from regulators to create the right policies and the right environment, and also from industry to develop new technologies and new solutions that can better solve this connectivity issue. And especially, it's not only about covering areas, it's about providing affordable solutions. So I'm excited also to see the variety of solutions. I think we will need a combination of different solutions, and all of them have something to offer that makes them very special for this challenge. So thank you for watching this session, and thank you again. Please continue attending the DSA Summit.